Now, if I saw it just in one data set, I would say, well, there's something that we need to explain there. It may not be significant. But when you see it in all of these data sets, the trend seems to be very clear. And it, therefore, as a concern for me as a scientist, that in fact the climate system may be accelerating and that climate change may indeed be closer than we thought. But what is the IPCC able to say about the future? There's a very complicated diagram. I'm not going to do all of it. But here are some results from several, about 20 odd models of what will happen to the global average surface temperature in two time periods. The orange is in the period 2025, 2030 or something, and the purple one is at the end of the century. And what this is are probability distribution functions, sort of Bell functions that teachers often use in marking exams. But and this is what they're observed from global models, and I'll talk about them a little bit. But there's several points that are important from this slide that I want to make. The first is that for all scenarios, the temperature change over the next 20 to 30 years, and these are different emission scenarios, is essentially the same. It's about 1 degree Celsius. In other words, all of these models are saying that regardless of what the energy supply and demand and use may be over the next 2 or 3 centuries, this amount of warming is virtually inevitable. We're going to experience about 1 degree Celsius. In other words, that part of history is already written. If you go out to the end of the century, then depending on which scenario you use, you have different results. But even for the one with the lowest emissions, that's the B1 here, it's at least 2 degrees Celsius. So that's the first point. The second is, that's the second point. The first point is what's happening over the next 2 or 3 decades. The next is what's going to happen over the next century. But the third point is, if we freeze, or are able to freeze the concentrations of greenhouse gas in the atmosphere, let's say at 2100, which of course we know we can't do, but just do the scientific experiment, and then run the models, then you see that the temperature continues to grow, to increase. This is also true of sea level rise. In fact, this is because there's an inertia in the climate system, that even though we stop the forcing at a certain time, the climate system has this inertia, it's got this memory, and it's not going to let us forget. You can also see it down here. And this is an experiment where we keep the concentrations of greenhouse gases at today's levels. Again, a practical thing to do. And you see the temperature slowly increasing. And what that says is that over the next 2 to 3 decades, there's going to be an increase of at least 0.1 Celsius per decade. And that's because of the inertia in the climate system, what we've already done to alter the composition of the atmosphere. But the final point is that all of these scenarios, and these colours refer to different emission scenarios, over the next 2 or 3 decades, virtually lie on top of one another. And that's because of a different sort of inertia. That's the inertia in our socio-economic systems, the systems we use to produce electricity, to get us around our cities. And so if you put that into the calculations as well, then the warming is not 0.1 degrees Celsius, it's twice as large, it's about 0.2 degrees Celsius. So that's what the future is telling us, globally. What about the Arctic? Well, the changes we have seen in the Arctic are expected to continue, and maybe, as I've suggested with the sea ice, actually accelerate. There are positive feedbacks. For example, when you melt the ice, you're replacing a white reflective surface by a dark absorbing surface. And that absorbing surface, which is the ocean in the Arctic, takes in heat. And the longer the ice is clear, the more heat it will absorb. And the more heat it absorbs, the longer it's going to take for the ice to form. And incidentally, if you want to continue the argument, The longer it takes for the ice to form, the later will winter occur in the Arctic. And as David Phillips said, Arctic winter doesn't happen in Toronto until it starts in the Arctic. So we may very well see a recurrence of last winter, where winter did not start until the middle of January. So the message from this and everything else to me is clear. Is what we've seen so far is not in fact going to get better. And the irony is that this is happening in a part of the world whose contribution to climate change has been small. It's also happening to a people whose bonds to the earth are extremely close, and to have learnt over the generations how to live with some of the harshest climates in the world. But their coping capacity is being strained, and communities, infrastructure and ecosystems are becoming far more vulnerable. As I said, there have been recent media articles that have reported that the Northwest Passage is now open for shipping. Well, actually, it's open for shipping most years, if only for a limited period of time, and it does require that you're accompanied by an icebreaker. But this year is different, and as I said, according to scientists on the research vessel, the Amundsen, they have not been able to see any multi-year ice in some of the narrower passages of the Northwest Channel. And as I said, the total sea ice extent this year from our satellite observations is the lowest it's ever been over the last at least 30 years. But decreasing the ice in the Arctic is more than just a scientific curiosity. For Canadians, the Northwest Passage, which traverses the Arctic, is a matter of security and of sovereignty. The number of passages through the Northwest Passage over a whole of history has not been much more than a dozen or so, but there are estimates now that with the Northwest Passage opening, that could increase to in the order of 12,000 vessels a year. So it's clearly going to have an impact in the north, on the Northwest Passage, and for the people who live there and for their environments. So to conclude, the impacts in the Arctic are not going to occur in isolation, but in the context of technological, economic, social and ecological changes. For example, the effects of climate change, they occur in the context of numerous other factors, including the effects of resource extraction, unsustainable development, and the pervasive effects of globalization. As far as many people in the north are concerned, climate change is not only obvious, but further change, which I've said is now virtually inevitable, poses real dangers. The Inuit are among the first people whose lifestyles are already threatened by climate change. They are indeed a fragile people. And according to the IPCC's fourth assessment report, the communities are adapting to climate change already, but their resilience is being severely tested. In other words, adaptation to climate change is no longer simply a policy option, it is becoming a policy imperative. So let's not be like the people in this cartoon. Let's see the writing on the wall before it's too late. We all have an interest in the integrity of the environment on which we all depend for providing essential goods and services. And finally, we do have a moral responsibility. For what defines us as a civilized people is our concern for others and for the environment. Thank you.